Hello and welcome dear learners to the NPTEL course on Nutritional Epidemiology, Your Way Towards a Healthy Life. In the Module 2, Study Design and Epidemiological Methods for the Chapter 21, we'll be talking about the biases in nutritional epidemiology. Why biases matters and biases versus random errors, the major type of bias and special biases in nutritional epidemiology. Also, we will be talking about minimizing the bias and case discussion on bias in nutritional epidemiology will be taken ahead. So, why bias matters? In nutritional epidemiology, establishing a robust causal link between dietary exposures and disease outcome is notoriously difficult. Diet is a complex, continuous, and highly correlated exposure matrix. Bias matters because it represents a systematic error that distorts the true association between dietary factor and a health outcome. Unrecognized or unmitigated bias leads to spurious associations, treating internal validity and consequently misguiding public health nutrition policies, dietary guidelines, and clinical recommendations. So you can understand why bias needs to be taken very seriously over here. Recognizing the systematic errors is a critical step in rigorously study design and interpretation within the hierarchy of evidence. So you can understand over here what is the difference between bias and random error. On the other side, you have the random error, that is precision error, and bias, that is called as systematic error. So systematic deviation from the true value is what bias is, and fluctuation around the true value is what the random error is. Consistent direction, example, always underreporting, which is being seen in systematic error, that is bias. And in random error, it is oscillates around the truth. It is around the truth that comes as a random error. Effects on the estimate is invalid in bias that points the estimate, whereas in the random error the effect on estimate is less precise but not average valid. Effect of sample size in bias does not appear with large samples, and effect of sample size in random error shrinks with larger samples. So you can understand how it comes with the precision versus with the systematic error. Example in nutrition, if I have to give you about the bias, is underreporting of total energy or social desirability and selective reporting. For the random error, it is daily variation in food intake with person fluctuation. So this is a very clear-cut differentiation between bias and random error. Now we'll try to understand what are the major types of bias. There comes the selection bias as first, followed by information bias, that is measurement bias, and confounding bias. What is selection bias as such? Selection bias occurs when the systematic criteria used to select the subjects for a study or factors influencing their attention are associated with both exposure and outcome. You can understand with the example of the prospective cohort study, where the cohort is recruited, healthy diet is in green given as low risk, average diet which is being shown in brown, which is an average diet, and in red, that is poor, that is called as high risk. After 20 years, you can see loss to follow-up, poorer diet and higher cardiovascular risk. The impact is the remaining sample appears healthier, leading to an underestimate of the true diet disease association. So you can see there can be overweight, obesity, high risk participants, poor dietary habits, higher risk of CVD, or more likely to drop out. So this is a selection bias. So for example, loss to follow-up in a 20 years prospective cohort study where the participants with the poorest diet and highest cardiovascular risk systematically drop out, skewing the remaining samples. So the exit may be likely to be dropout. Now we can see the information bias, that is called as measurement bias. This bias arises from systematic errors in measuring the exposure, outcome, or covariates. Non-differential misclassification versus differential misclassification. So in non-differential misclassification, it occurs when the error is measuring diet is independent of disease status, often pulling results towards a null. So you may have a diet assessment, same type of error in both the groups, cases and controls, and the estimate effect is towards null. Where versus in the differential misclassification, it occurs when the error depends on the disease status. Example, recall bias in case control studies where the cases remember their past diet differently than the healthy controls. You can find a difference where always from the null over the underestimate. So the common sources of information bias is recall bias, reporting bias, under or over reporting, and misclassification bias. Interview bias. So what is the impact? Impact can either exaggerate or underestimate the true diet disease association. Now, the third as in confounding bias. Confounding bias, while technically distinct from bias as it represents a true though non-causal association, confounding acts similarly by distorting exposure-disease relationship. A confounder must be associated with the dietary exposure, an independent risk factor for the disease, not lie on causal pathway. So the confounder, for example, physical activity, smoking, socio-economical status, can affect the dietary exposure. Example, high red meat intake or disease outcome might be cardiovascular disease. Examples of the confounder can be physical activity, smoking, socioeconomic status, other dietary factors, or alcohol consumption. What is the impact? The impact of the confounder is associated with both the dietary exposure and the disease, leading to spurious or exaggerated association. So this way you can understand the major types of three biases. Now, what is spatial biases in nutritional epidemiology? So there are four types of biases in nutritional epidemiology: the measurement error in diet, reverse causality, social desirabilities bias, and energy misreporting. So in the measurement error in diet, inaccurate estimation of dietary intake due to limitations of dietary assessment methods. It can be FFQ, 24 hours recall, or dietary record. The example is underestimation of portion sizes in a food frequency questionnaire, where there can be a measurement error which a respondent is difficult to gauge. What is the impact? It can weaken, or in some cases it can distort the true diet disease association, what actually the purpose of the estimate is. So how to minimize this measurement error? You can use a validated tool which is pre-tested, or multiple dietary assessment actually to curate or to minimize the error. Portion size aids and training to the interviewer or someone who is trying to assist actually for the questionnaire to reduce this. Adjust for total energy intake to take a cumulative result of the assessment. Use biomarkers which are doubly labeled, water, serum carotenoids, and other, so you can get a clear or closer estimate of the diet assessment. Then comes reverse causality. What is reverse causality? The disease or preclinical condition influences dietary intake rather than diet causing the disease. So there is early disease symptoms and change in diet. Okay, so you can understand where, as an example, if I have to quote it for relating People with early signs of hypercholesterolemia reduce fat intake before the diagnosis. So what will happen? It will be closer to the disease condition but not the exact disease condition. The impact may lead to false, inverse association or obscure the real effect of the diet. So the diet should come after the disease occurrence. So how to minimize this reverse causality bias? You should use a prospective study design, which is after. Exclude early years of follow-up lag analysis, which is very important to reduce this bias. Also, you can repeat dietary assessment, which is very oftenly done to improve the assessment. Also, careful interpretation of the finding is very important for the researcher to do it if you overcome or you try to overcome this bias. Then comes social desirability bias. This bias, the participant report what is socially acceptable rather than their true dietary intake. So there is a difference which is being put as an subjective or under the pressure of social desirability. Okay, there is one thinking that I should eat healthy, which is being stated over here for a person actually over here who is in the dilemma. Where versus with the social desirability, the person will say, I will report only healthy foods. Okay, so what is the effect? There can be over reporting fruits, vegetable, whole grains. The person may be in that social desirability. Where versus there will be under reporting for sugar, food, fried food, alcohol, beverages, and so much of things. You may say example of over reporting of veggies, fruits, intake of under reporting of sweets, candies, snacks, cakes, alcohol and beverages. What is the impact? The impact leads to overestimation of healthy diet, which will make a very different picture, and underestimation of unhealthy diet, which is not being told. So how to minimize this bias? So you can assure confidentiality to the respondent and try to take the original information. You can also use neutral or non-judgmental questions, which will make it very clear to overcome this bias. Also, you can use biomarkers and objective measures to estimate accurately the desired information. Also, you can validate self-reports where the respondents can also confirm the given answer. Then comes energy misreporting. So this is a bias where the systematic underreporting or overreporting of total energy intake is done. In underreporting, which is very common in all diet assessment, the reported intake is less than the actual intake. Where versus there might be in proportion, measurement, timing, volume, type and so many other underreporting can be there, which is very usual. Where versus for the over-reporting part, which is lesser common, where reported intake is more than actual one, which doesn't seems to be there. Might be in some cases we can see this. Example of this energy misreporting can be overweight individuals underreport might be because of the desire, shame and usual habit. Calorie dense food and total calories also can be seen to be shown as underreporting. What is the impact of this? The impact is distorts the nutritional intake. Estimates can bias diet disease association, which is where the impact is already seen on a lower side. How to minimize this bias? You can use multiple 24-hour recalls which can reduce maximum of this. Energy intake plausibility checks like Goldberg's cutoffs. Also the use of biomarkers is advised where you can have a doubly labeled water. So you may understand I have taken it, again you are taking it, so you may get a sort of a check. Also, statistical methods to adjust for misreporting. So you can overcome with the help of the statistical method if there is misreporting done. Now, we will understand minimizing bias. How to take ahead minimizing the bias. So in all the 4 different phases, particularly we can minimize the bias step by step. In the design phase strategies, where for the randomization for the trials, suppose you have a group A and group B, which eliminates the confounding bias by design. Randomization, where random assignment of participants can be done prospectively on the basis of the cohort design, where versus on the prospective cohort design that tracks forward reduces the recall bias. Also, in careful sampling, you can ensure the representativeness, document and non-response participant by ensuring this, and you can include versus exclude for those participants very carefully. So this way in the design phase, you can do randomization, prospective cohort design and careful sampling to reduce or to minimize the bias. In the exposure measurement, what can be done? There are also 3 types over here: multiple past 24-hour recalls or food records. These are the 2 ways. Out of the 2 ways, in the very first, they use multiple past 24-hour recall or food records, which reduces the memory or portion size error, and you can calibrate the self-report with the biomarkers, which will help you to give the exact measurement. In the second case, what you can do, calibrate self-report with biomarkers, which is also a very feasible calibration, a regression calibration, which will give you a very exact information. Also, there can be a third way, that is harmonized dietary instrument. For comparability across the studies, it is very important that you can harmonize the dietary instrument, which will give you a very closer and reduce the exposure measure. In the third case of minimizing the bias, the confounding and effect estimation adjustment can be done. There are 3 ways to do that. Pre-specify confounders like age, sex, BMI, PA, education, income, smoking, collect carefully. Multiple regression, propensity, score method, structural models. This can be done to reduce the residual confounding, which is pre-specifying confounders. Especially we use age, sex, BMI, education, income and smoking. And in multiple regression, we can use the propensity score or structural modeling. Then the third is transparently report adjustment sets, where it can avoid the over adjustment for mediators. Reporting and analytical transparency is also one of the way of minimizing the bias. There also you can do it by pre-register study protocols and analysis plans. This can be done on public registers. Registers all analysis and avoid selective reporting, which can report both positive and null findings. Risk of bias tools in systematic reviews. Use risk of bias tools. So this can be adapted for nutrition separately, quality from bias in systematic reviews. Now we will have case discussions. There are 2 sets of case discussion that we will be discussing about. One is of a global studies and second is of Indian studies. In the global studies, we will have dietary fat and heart disease. Historically, in the Western countries, it has been seen, and the observations that are made are suggesting that higher fat increases cardiovascular risk. The confounding bias over here can be smoking, physical activity, and socio-economic status. What were the initial results of most of the global studies? They were overestimated harm of fat due to an unadjusted confounders. So confounding bias was seen something to be adjusted over here. What are the evidence inside? Nutritional epidemiology criticized for difficulty accurately measuring diet and reliance on observational design, leading to misleading confusions if bias are not addressed. There is also an association of beta carotene and lung cancer. Observational versus randomized control trials. Observation where high beta carotene lowers lung cancer. Healthy user bias confounding overall and healthy lifestyle is something where you can use as a confounding bias. In RCTs, beta carotene supplement increase lung cancer risk in smokers. So, interpretation is observational finding confounded by healthy lifestyle patterns. So, you can have a differentiation to be seen over here. Sugar intake and obesity. The global surveillance data states that there is energy misreporting by most of the people who take more sugar versus social disability will also become as a diet actually where the reporting is under. So, overweight individuals underreport energy intake, especially sugar and fat, weakening the association. So, global dietary surveillance which is done in multiple countries give the comparison that there is measurement bias and selection bias, non-standard data and misleading to international comparison and policy direction. Weber says in the Indian studies you may have diet and diabetes in urban India, where you may understand that there is a roar to be seen that India is having more number of diabetic patients, particularly in urban setups. The context is the participants underreport oil, sugar, processed food and beverages. Underestimation of diet diabetes association, where the bias is mostly being coming from social disability bias or sometimes from recall bias in some areas. The national nutrition surveys which are supported by NFHS and NSSO, which usually gives us a ecologic policy, household versus individual intake, where you can take intra-household food distribution, measurement error or gender age differences can be coming as some sort of differences from these studies, where you can get a very important issue of intra-household food and distribution of food which leads to miscalcification. Nutrition transition studies in India, where you can find a rapid dietary change due to urbanization is one way, and in the other way you may find transition to processed food. So there is a rapid dietary change in urban setups and a traditional to processed food which is also being seen as an habit. There comes a confounding socio-economic status and urbanization which is putting this as a bias, where the urban samples are over-presented. So what is the evidence? The food system inequalities and changing environment influence patterns, difficult to isolate diet effect from income, lifestyle and access to healthcare. So these are very important to understand the nutrition transition studies in India. Micronutrient deficiencies such as iron, vitamin A, vitamin D, where you can come across a measurement error, misclassification bias, and the issue comes with poor recalls of proportion sizes. Seasonal variation in diet was not captured, also leading to inaccurate estimation of deficiency prevalence is also being seen. So you can understand there are variations in diet and diabetes in urban India, national nutrition surveys which are giving us a greater information towards adding for the nutritional epidemiology and nutritional transition studies in India, which are backed. Also, micronutrient deficiency studies are also done. So with this, we come an end to this chapter, where bias in nutritional epidemiology is being referred to systematic errors that distort the true relationship between diet and health outcomes. The bias is commonly arising from issues like inaccurate dietary measurement, confounding by lifestyle factors, and selective reporting, which is very being common. This is because the diet is difficult to measure precisely. These biases can lead to over or underestimation of association. So there are some special challenges that include energy misreporting, social desirability bias, and reverse causality that can affect it. If not addressed, this bias can mislead research findings and public health recommendations. Therefore, carefully study design, accurate measurement, and transparent analysis are essential to minimize this bias and ensure valid conclusion. So with this, we come an end to this chapter. You can take these references as a guidance for this, and you can understand more in detail about the nutritional assessment. Thank you.